worked on that yesterday. Problem number 1. Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t is equal to negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. Now, here's my question for you. How high was the cliff? How high was he when he jumped off the cliff? Which one of these is the initial height?
480.
He's at 480 feet is his initial height, and his speed's not going to make that much difference to us, but he's jumping at a speed of 16 feet per second. And, of course, that's our gravity that's going to affect him. So let's go over here and kind of sketch the picture. Now, think about it. At 0 time, I'm going to just estimate it. I'm just going to call it that point right here. He's at 0 time, and he's at 480 feet, which is where he's going to jump from. Now, we're going to put a little bit of rise on it because I didn't just say, you know, he could literally just dive off of it, but we're kind of, it says specifically that he jumped, and with that parabolic curve, and mine is probably not, I know it's not to scale, but we're going to put a little bit of rise on it. Now think about your key points, and every problem will ask for everything. This is going to be his maximum height and the time at that height, remember? Maximum height, time at that height. And even though if it asks for height, you're still going to find the time first. You'll see why. That's your independent variable. And then remember, this is when he hits the water. So we know at that point that we don't know the t, but we know the height is 0. But then you also have to remember that even though realistically there's not negative time, but your calculator doesn't know that. Your calculator knows there's another 0 back here. So we'll see what happens with it when we talk about ordered pairs. The time would be negative something, which doesn't happen, and the height would be 0 because he didn't start on the ground. Yeah, A. Now, a lot of times these problems will go together. How long did it take for Jason to reach his maximum height? And B, what is the highest point that he reached? So my bottom line is in A and B, and I'm just going to actually put them together. We need to know his maximum height and what time that was. Well, we usually find the vertex first. And how do I find the time? T equals, and how do I find the t or the x of the vertex? See, think about it. This is the vertex. That's that negative b over 2a. So this is, and I don't want to say maximum time, because maximum time would be how long he's above the water. So we can just say it's the time at the vertex, I guess is the best. I think if you put negative b over 2a, you'll be okay. And then you'll have opposite of 16, because b is 16. So I've got negative 16 over, and then 2a is going to be the same. As long as you're on Earth, it's going to be 2 times negative 16 is negative 32, which reduces to 1/2. Now, I do want units, because I want to know what this is. And I'm probably going to change it to 0.5. But what is that? Is that feet or is that seconds? That's the time at his maximum height, and it's 1/2 seconds. And then we want to know what his height was. Well, think about your formula. Your formula says h of t is equal to negative 16t squared plus 16t plus 480. And we now know t, and this is just that function notation of telling you what you know, and we need to find h. So this is just the same as if I just said h equal. It's the same thing, like y equals mx plus b, or f of x, or y of x. I mean, you can write them different ways, but I just need to know this when time is, and I'm going to use 0.5. It's just going to be easier on the calculator. So I'm going to do h of 0.5 and put 0.5 in all the way across. Now, you just have to be careful with that first one, because notice that the negative 16 is not being squared. Only the time is squared. And time-wise, I don't think I'm going to go through that. I'm just going to go ahead and do the arithmetic for you, but I would just type negative 16 times, I could use parentheses or I could use the times button, the star, and then 0.5 raised to the second. Just make sure you're not raising all of this to the second power. It's only the time. And then plus, I think, well, I think I did type this last block. Let me see if I still have it on here. And then I did 16 times 1/2. Yeah, there it is. Except that's not the answer. This must be the later one. Another one. Let's see if I can find it. No, I don't know where it is. Maybe I didn't type it. I don't remember. But anyway, it comes out 484 feet. So obviously my graph is not to scale, because if from here to here is 480 and from here to here is just 4 feet, he only went up 4 more feet. So 484 is his maximum height. And then there's the time, like that. 1/2 second, at 1/2 second, which is pretty realistic, you know, just quick. I mean, it's a quick jump. You know, we think it would be longer time, but it's just very, very quick if somebody dives. And then C says, and then we're going to add a D here. I think I added a D last block, yeah. C says Jason hit the water at about how many seconds? Now, look at what you've got. You've got h of t is equal to negative 16 t squared plus 16t plus 480. Now, which one is this? What is 0? That's our what? That's the height. Well, in your equation, then that's saying the height is 0 equals, I'm going to put 0 in for the height because that's what you just told me it was, 0 feet is negative 16t squared plus 16t plus 480. Now, don't get all crazy over that because it's no harder than this problem if you have the calculator with you. Okay, you got that written down? Okay, I give you that problem and I say solve it. It's quadratic. It has 2 answers, right? How can you find those 2 answers? Will that one factor? Does x squared plus 5x plus 6 factor? I think it does. Isn't it x plus 2, x plus 3? And then you get your 2 answers. But what if it didn't factor? What would I probably do? Use what? What can you solve a quadratic with? What's the good old program Ms. Brown gave you? The quadratic formula solves quadratic equations. And what's nice, it gives you them real, rationally irrational. It gives you imaginary ones, which don't really make sense on these, but it gives you those answers. So here's the question. Does this factor? I have no idea. It does have a GCF. You could take out negative 16 or you could take out just 16 if you wanted to. But why go that route? Use your quadratic formula. I mean, that's what it's there for. And that's what quadratic formula will give you. Here's what I wrote last block. Let me do it this way. I wrote quadratic formula will give you x-intercepts, also known as zeros, or in this case, its beginning and its ending when he hits the water. Well, there really wasn't, the beginning didn't really make sense, but it's still, if he had started on the ground and then jumped over into the swimming pool, then we would have looked at those 2 times. 0, he's standing there, 0 height, and then jump into the water. So, if you look at it this way, we're saying, put my variables backwards, that we know the height is 0 and there's 2 answers. We know quadratics always have 2 answers. So when you punch it in, what does it give you? Time equals what? I think they're exact. Now you will have some in your classwork that are not exact. You'll have to round it. It usually says to tenths. But did you type it in? Got your calculator? Let's see if my program's running. Yep, negative 16. I think all of these come out even, and I don't know if that's a good thing or not. And then 16, and then 480. And we got negative 5 seconds or 6 seconds. Now, sometimes they both work. In this case, there's no such thing as negative 5 seconds. I mean, did it take him 5 seconds to climb up there? Probably not. But I mean, that's the case of in the idealistic situation. That's that time from here back to here. But that's probably not the time that it took him to get up there. But that's what it's actually giving you. Well, we know that one doesn't happen. I would not erase it. I would just exit out. And we know that he hit the ground, he hit the water at 6 seconds. And then I would give you sometimes, well, let me go ahead and do this one, and then if I have time, I'll tell you where I could give it to you as a tricky situation, but I tried to go back and fix them so that they weren't all, like I said, super crazy. So this is what I asked them last block. What is height at 4 seconds? Well, my first question is where is he at 4 seconds? Looking at your picture, even though it's not to scale, if this is a half a second and he hits the ground at 6 seconds, then it's somewhere in here. Not necessarily halfway because he's speeding back up, but it's somewhere in this vicinity. So I know it's somewhere between a half a second and 6 seconds is that he's going to end up being, let me back up. I know at 4 seconds he's going to be somewhere in here between 484 feet and 0 feet as he comes back down. Now, what is it asking? It's giving you 4, and it's asking for h. So when you look at your formula right here, then this is the one we don't know. So we're trying to solve for h of the time, but we know the time. So we're actually doing h of 4. That's why we like function notation, because you literally see your x value, in this case time, right there. And then we've got negative 16 times 4 squared. This is the one I typed because I typed it like this. And then I did plus 16 times 4 and plus 480. And I just typed negative 16 times 16 plus, this was 64, plus 480. And you should get 288 feet. That's the one I had on my calculator a while ago, which is somewhere in this vicinity over here. Now, I've given them problems that would say, not so much this one, but I'd say, what is the height at 10 seconds? Well, it's 0. You know, it's not going to go down negative. I mean, after that, it's something more than 6 seconds because he's not going to go. It's kind of hard when it's water, but again, we'll say you have to be careful as to what it asks. So sometimes they are a little bit tricky. Is it possible? You've got a couple of questions in your classwork that says, is it possible to do this? Number 2, page 84. Okay, got a little toy rocket.